Good morning and welcome to the mold webinar, energy-related mold and moisture. My name is Mark Powell and I'm with Kentucky Housing Corporation. I want to welcome everybody to the webinar this morning, and we'll just go ahead and get started. Energy-related mold and moisture, awareness and impacts for weatherization. This is provided by the U.S. Department of Energy Low-Income Weatherization Program. This is a training overview and DOE guidance. Now, why do we have this mold training? Well, effective November 12, 2004, the U.S. Department of Energy issued Weatherization Program Notice 05-1 and Section 5.14 of WPN 05-1 titled Energy-Related Mold and Moisture Impacts require that weatherization crews receive specialized training in the recognition of conditions that promote mold growth they may encounter in their weatherization work and how best to prevent creating new mold conditions. Now, at the same time, crews need training in how to treat less extensive mold conditions they may encounter in certain homes. Now, this training is provided by DOE to meet the training needs of Sections 5.14. DOE guidance regarding mold-related weatherization. As of November 12, 2004, the Weatherization Assistance Program is not a mold remediation program. DOE funds should not be used to test, abate, remediate, purchase, insurance, or alleviate existing mold conditions identified during the audit, the work performance period, or the quality control inspection. Weatherization services may need to be delayed until the existing mold problem can be referred to another agency for funding of remedial action. Continuing on with WPN 05-1, in program year 2005, all states will be required to amend their health and safety plans to include a protocol for dealing with mold, which will include a specific policy when encountering homes with mold growth. Effective immediately, all states should ensure that their local agencies include some form of notification or disclaimer to the client upon the discovery of a mold condition and what specifically was done to the home that is expected to alleviate the condition and/or that the work performed should not promote new mold growth. Continuing on, DOE funds may be used to correct energy-related conditions to allow for effective weatherization work and/or to assure the immediate health of workers and clients. Now, here's some pictures down here showing some examples of what you can actually find out there in the field with mold conditions. You never know sometimes what you'll run into, so seeing this training will help you to have a more trained eye and what to look out for. So continuing on, summary of the mold guidance will include training, which will give you an understanding of conditions that promote mold growth, prevention of mold, treatment options that are available, assessment, which includes client notification or disclaimer. We will discuss the health of workers and clients and talk about the state protocol. Each state will develop a protocol with specific policy. Now, the basic steps and actions involved in this process begin with DOE Program Notice 05-1. It comes down to assessment of the situation and whether a notification or disclaimer needs to be provided. And then state protocol determines the action. You have the option, depending on the circumstances, to delay work until conditions are corrected, refer to another agency for cleanup, or it might be determined that no cleanup is needed so you can proceed, or that agency cleanup of energy-related conditions are available and possible to do, and you will proceed. What you will learn in this webinar, as a result of this training, crews will learn what DOE requires regarding mold-related weatherization, building science related to molds, recognition of conditions that promote molds, best weatherization practices to prevent molds, client disclosure of molds, and how to treat less extensive mold conditions. Now, why are molds a concern? Well, while dormant mold spores are always present inside a home, active mold growth indoors is not normal. Molds can present health risk for crews and clients, and uncontrolled mold growth can cause severe and permanent structural problems. And failure to recognize conditions of mold growth may worsen existing mold cases or cause molds to actively grow. In a nutshell, that's why molds are a concern. Now we're going to begin with Lesson 1 to give you some background on molds and the health effects. What you will learn in Lesson 1, you will learn where molds are generally found in a conventional and mobile home, why molds receive more attention today, some terms related to molds, and the health effects of molds. Now, home molds are real. Here are some pictures showing actual mold growth in different parts of a home. Here's a picture showing mold growth on a suitcase that's stored down in a basement that has high humidity, mold on the ceiling of a crawl space, and mold in the ceiling of a home. Now, it is important to take precautions to limit your exposure to mold and spores as well. We will also talk about hidden home molds, for example, molds that can go behind the wall covering of a tub enclosure in a bathroom. See these areas here where mold is growing? Mold inside a furnace cabinet, mold growing on the back side of wallpaper. Yes, believe it or not, mold can actually grow in a place like that as well. Now let's talk about where mold problems may be found in a home. For example, around a dirty air conditioner, dirty humidifiers, a bathroom without vents or windows, kitchens without vents or windows, dirty refrigerator drip pans, a laundry room with unvented dryer, an unvented attic, carpet on a damp basement floor, bedding, closet on an outside wall, a dirty heating or air conditioning system, and finally, water damage around the windows, the roof, or in the basement. Now let's take a minute and talk about molds in mobile homes. Now mobile homes are kind of unique because of the very nature of their construction. They have a small volume, which allows for less dilution of relative humidity. They have many cold surfaces for condensation to come and exist. They provide many sources of processed wood, which is mold food. The roofing does not provide any ventilation, or ventilation is poorly distributed. And in the crawl space of a mobile home, there's typically no ventilation, or it's poorly distributed with tight skirting, and there can be plumbing leaks in mobile homes, which, taken in the aggregate, can compound the problem and create a lot of opportunities for mold growth. Now, why are we talking about mold today? Well, it's always outside the background levels of mold. Excessive building tightness as a result of reduced infiltration, reduced ventilation, poor construction practices, improper use of building materials, and there is more media and public awareness. So that's why we have mold on our mind a lot more today. Now, what are we talking about concerning mold? We're talking about fungi, which is naturally occurring organisms that are essential to decay of organic matter. Mold and mildew, terms used to describe fungi. Biologicals, water source, indoor air quality problems like fungi. Bioaerosols, biological aerosols, airborne droplets containing mold spores, bacteria, and microbial volatile organic compounds, also known as VOCs. Mycotoxins are among the most potent carcinogens produced by these and other fungi, Aspergillus, Penicillium, and Stachybotrys. Now, these are long known as agricultural threats to livestock and humans from animal feed and grain dust. Mold growth. For example, down here close to this baseboard, they release tiny spores. The spores travel in the air, they settle on surfaces, and they get into water. And molds will multiply in the right conditions. Problems occur when colonies or spore levels are large. Active mold growth indoors is not normal and can present health risk to crews and clients. Health effects, let's talk about that. People react to the spores, the fragments and the proteins, the mycotoxins, the microbial volatile organic compounds, and people can react if mold is living or dead, so remember that. Mold must be dealt with before weatherization can be performed. Mold is a health concern. Generally accepted, the response varies. Young children and elderly are more susceptible, especially those with compromised immune systems, and there is a cumulative effect from prolonged exposure to mold. Now for crews and clients, typical symptoms related to mold exposure would include nasal and sinus congestion, sore throat and coughing, shortness of breath, chest tightness, eye irritation, headache, fatigue, rashes, and a known asthma trigger. Stachybotrys, also known as the black mold or the bloody mold, was first made widely known and discovered in Cleveland, Ohio between 1993 and 1994. The impact resulting from flooding. The health effect on children included bloody ulcers and also the death of 6 children. It was first described in 1837 Prague around wallpaper in long saturated cellulose. Mold is slimy when it's active, and mold spores are released upon drying. Now let's move on to Lesson 2, conditions that promote mold growth. What you will learn in Lesson 2, what factors influence the growth of mold in homes, and how factors that influence the growth of mold relate to weatherization. Conditions that can promote mold growth. Here are some clues to mold control and 9 conditions of mold growth. 1, mold spores present. They are everywhere. 2, food, organic materials. 3, moisture. 4, building tightness. 5, temperature. 6, oxygen range. 7, time. 8, improper Wicks assessment, diagnostics, and measures. 9, lack of home occupant knowledge and maintenance. Mold growth. Number 1, mold spores present. Fungi consist of approximately 25% of Earth's biomass. The spores are everywhere. And the estimated fungi species exceed 1.5 million. That's a lot of different species of mold, isn't it? Now, dormant spores can survive for many years without germinating and spreading. Now, the bottom line is this, guys and gals, is fungi spores will be in the homes you audit and weatherize. 2, organic material, which is a nutrient source. Molds secrete digestive fluids that decompose the material substrate, making nutrients available. Examples, processed wood, cellulose, which can be sheetrock and insulation paper, natural fibers such as cotton and wool, for example, carpet, rugs, and upholstery. Dirty water, known as also sewage water, is full of organic material. Inorganic materials. Now, molds can't get nutrients from inorganic materials such as metal or glass, but can grow on the dust or soil present on those surfaces. Nutrient source example, inorganic material, rubber and synthetic carpet, no mold. Organic material, organic jute backing on carpet and padding, liner. Now check out the mold. It can grow on these surfaces. 3, moisture. Moisture control is the key to mold control. Here's a picture of a headboard in a bedroom that's got a very high humidity condition going on, and that has allowed for mold to actually grow on the headboard of that bed. You wouldn't think that could happen, but it does actually happen out there. And excessive humidity, water intrusion in a bathroom down here by the tub. You can see that very clearly. Moisture from water intrusion. For example, water from plumbing leaks such as sewage backup and flooring, foundational seepage from lawn watering, snow and rain runoff, capillary movement, wicking onto organic materials, and dirty water is the worst. Here's an example of a crawl space that has a lot of moisture and water in it, and you should not cover up these problem areas. You should treat those and dry them out before you do any such thing. Basement mold. Why the mold? Well, there's cold surfaces which are causing condensation, and there's an exterior water source possibly. See that mold in there? Now, when you have conditions like that, do not insulate or cover until the moisture problem is dealt with. Ceiling mold. Very bad case right here. You need to check for moisture from these sources. 1, ice damming. 2, insulation drift. 3, no insulation. 4, improper attic or exhaust venting. 5, roof leak. 6, AC condensation. Any other ideas? There could be a lot of other situations. Mold growth, moisture, excessive humidity. 50% and greater relative humidity is optimal for mold growth, and an average family of 4 can generate over 6 gallons of moisture per day. Humidity is water vapor. Water vapor with cool surfaces is combo for creating condensation. Water vapor moves into walls and ceilings via diffusion and air leaks. Humid air plus cold surface equals condensation. Moisture flows warm to cold, more to less. Moisture, excessive humidity, warm humid air plus a cold surface creates condensation. In a hot climate, outside warm humid air plus a cold surface on the inside wall. In a cold climate, inside warm moist air plus a cold surface on the outside wall can create condensation in these types of situations. You need to avoid negative pressures in the south. Here's an illustration that shows a situation where there is a leaky air handling unit and supply ducts, and negative pressure is caused by the leaky ducts. There's actually infiltration going on coming into the building envelope caused by that. Infiltration of warm humid air can come into walls, through chases, into rooms, and condensation on cool surfaces. Sources of home moisture. Believe it or not, an average family of 4 can generate over 6 gallons of moisture a day. For example, from the shower, they can generate a pint for each 10-minute shower. For clothes drying, 5 pints per load that's done. From a combustion, unvented space heater, 7.6 pints per gallon of kerosene used. If you're cooking dinner for a family of 4, you could generate 1.2 pints or 1.6 pints if you're cooking with gas per meal cooked. Floor mopping, 1.5 pints per 50 square feet mopped. Respiration for a family of 4, 4/10 of a pint per hour. Desorption of materials, seasonal, 6 to 17 pints per day. New construction, over 10 pints per day. Ground moisture migration, up to 100 pints per day. And 1 pint can increase the relative humidity by about 8% in a 1,500 square foot single floor home. So that's pretty amazing. Condition 3, let's talk about the optimum indoor relative humidity levels. Now, in this chart right here, the optimum zone to where the least amount of mold growth and the ideal relative humidity ranges exist are right in here. In cold climates, you would like to try to maintain between a 35 to 50% relative humidity, and in hot, humid climates, maintain a 40 to 60% relative humidity. High humidity caused by window condensation. The lower the window R value, the cooler the inside surface, and the greater chance of condensation. Now here's an illustration right here in the lower right corner of this window. You see mold growth caused by condensation. Water just literally staying on the window frame and allowing food and the condition for mold to grow. Condensation on the inside of a window pane, and then mold growth down here below this other window. So there's a lot of different places mold can grow. Now, high humidity with poor or no ventilation. Well, let's look at these pictures right here above the bathtub in the bathroom. See the mold growth here on the walls and in the ceiling around the exhaust fan. Is the exhaust fan vented to the outside? Maybe, maybe not. Or is the fan operating long enough to remove moisture? Situations like that do need to be investigated to see what has to be done to take care of that problem. Mold growth relating to building tightness. Now, since the mid-1970s, homes are built tighter, they're better weatherized, and they save energy. But without controlled ventilation, tighter equals less air exchange, tighter equals less moisture evaporation, tighter equals less pollutant dilution, and tighter equals the greater chance of mold growth. Building tightness continued. How tight is too tight? Well, one thing we can use to monitor that is the blower door system. We use this very, very heavily in the weatherization program. We would use the blower door and we would consider the number of occupants, the volume of air-conditioned area, and any mechanical ventilation that is already in place in that home. 5, temperature. Now, molds do love household temperatures. Molds can germinate and they grow best in warm temperatures. The optimum ranges is between 77 to 86 degrees Fahrenheit. Now, at cooler temperatures below 50 degrees, some molds will germinate, but they will grow slower. Oxygen. Molds require oxygen, but they don't require light for growth. So think about mold growing inside a wall cavity, for example. They can grow in the dark as long as they've got food and oxygen and moisture. And let's consider time when it relates to mold growth. Mold can grow fast. Some fungi can germinate in as short a period as 4 to 12 hours. That's pretty amazing, isn't it? Mold spores, like seeds, are released and carried by air or water to new locations. And if not dealt with, molds can spread in 24 to 48 hours. Mold growth relating to improper weatherization assessment, diagnostics, and measures. Now, the work you do may increase moisture levels and contribute to mold growth. For example, if there were improper blower door diagnostics, if there was over-tightening of the house, which could be creating a moisture buildup, improper ventilation levels, improper installation of exhaust fans, failure to apply energy-related health and safety measures. Can you think of more? Well, sure, we can always think of some more. Mold growth related to home occupant awareness. You need to alert occupants of home mold growth and possible conditions that may create moisture problems and mold growth. And here's a resource for the public provided by the Environmental Protection Agency. It's called A Brief Guide to Mold, Moisture, and Your Home. That is EPA publication 402K-02003. And you can get that by logging on to their website, which is www.epa.gov/IAQ/molds/moldguide.html. This concludes Mold Webinar Session 1. I want to thank everybody for attending this, and we'll see you in the following sessions. Have a great day.